right here we're going to graph the rational function f at x equals x squared plus 7x plus 12 over x squared plus 4x plus 3. So when you have these quadratics, you always want to factor them, and I've done it right here. Now, we can cancel out the x plus 3 factors, but we're going to have a whole removable discontinuity. So I'm going to take care of that at the end, though. So here's the good news. Our essential equation we're working with now is reduced to this, x plus 4 upon x plus 1. So let's find the vertical asymptote. You set the denominator equal to 0 and solve. So I get a vertical asymptote at x equals -1, and it's always going to be a vertical dashed line. Now to find the horizontal asymptotes, you divide the leading term in the numerator, which is just x. All I have to do is look here now. So I divide x by x, and I get 1. And that's going to be referring to y. It's going to be a horizontal line at the point y equals 1. So I have my horizontal asymptote. Let's find the zeros. We're going to set y equal to 0 and solve this equation. So x has to be -4. I mean, just think about it. You want to make the numerator 0, so if I pick -4, that makes it 0, and 0 divided by anything is 0. So at the point -1, 2, 3, 4, right here, it's going to be a point on the graph, 1, 2, 3, 4, x equals -4. Okay, now let's find the y-intercept. It occurs when x equals 0. So I have the point 0, and I'm going to look right here. 0 plus 4 is 4. 0 plus 1 is 1. So 0, 4. Okay, now asymptotes are just organizational tools to help you see what the graph approaches. Now, is it possible for the graph to go like this? Nope, because always go towards the vertical asymptote, and then the horizontal asymptote deals with end behavior when x gets really big. So the graph should look like this, and let's confirm that by picking the point x equals 1, 2, 3, 4, 5. So if I pick the point 5, remember, we just have to look here. So 5 plus 4 is 9, and 5 plus 1 is 6. So this is 3 halves. So 5, 1, 2, 3, 4, 5. 3 halves is literally right about here, 1.5. So it's all making sense. Now, the graph here is going to look like this. That's the only possibility logically, and we're going to confirm that with some points. So asymptotes are just organizational tools to help you see what the graph approaches. Really important to understand that, okay? All right, so let's pick the point x equals -1, 2. So at -2, I have the point -2 plus 4 is 2. -2 plus 1 is -1. So -2, -2. So it should have been right here, actually. Okay, so clearly it's going to have this pattern to it. So clearly it's going to be extended. So you could pick more points if you want, but it's clearly going to have that pattern to it, okay? Good job. And let's draw arrows here and here. Now, there's one thing we actually have to keep in mind. Remember how I said we have removable discontinuity at the point x equals -3? So if I pick the point -3, I'm going to get the point -3 plus 4 is 1, and -3 plus 1 is -2. So at the point -3, which is right here, sorry, 1, 2, 3, it's going to be, it says -0.5. So this point right here, I have to put a hole. It's not going to be on the graph, okay? So if you can factor and cancel out, at the end, you have to, because it all has to do with the fact that you can't divide by 0. You can essentially cancel this out, except for the case when x equals -3. So this point can't be on the graph. We have to do a hole right there, okay? So now the graph is complete. Good job.